So for the elimination method, that's our third method. So far we've solved by graphing. Sorry, highlighter already. It's just like in class. So we've solved by graphing, and we've solved using substitution. Okay, so when I do the elimination method, this honestly is a favorite of a lot of people, so it's going to be a preferred method. So the first thing we need to do is write the system so that both variables are aligned. And preferably we want it to be in standard form. So I want to have it, if I have an equation, one of them is 3x plus 2y equals 6. Maybe the other one is negative 5x minus 4y equals, I don't know, 15. Notice how I have my x's aligned. So they're lined up, and my y's are aligned. Oops. There we go. My y's are lined up. There we go. Okay, so that's the first goal. Second thing is that we want to eliminate, that's why it's called the elimination method, eliminate one of the variables and solve for the other. Another way of saying it is to cancel out. Okay, and we're going to use that or do that using combination. So we're going to combine two equations together. Okay, then we're going to plug the value, just like we did for substitution, of the variable we found into one of the original equations and solve for the other variable. And then we're going to write the values of the solution as an ordered pair. Again, that's just like in graphing and in substitution. Ordered pair. Okay? All right. So I'm going to do the easiest version today, and it really is pretty simple. The variables will already be set up to eliminate, okay? So we want both x's or both y's to have opposite coefficients. So that's one positive, one negative, those are opposites, of the same value. Okay, so that means if I have a positive 4 as a coefficient, that means that I also want to have a negative 4 as a coefficient. If I have a negative 3x, then I also want to have a positive 3x. Okay, they're opposite values, opposite coefficients of the same value. So a positive 4, negative 3, positive 3. Okay, so this is what you're going to have to ask yourself. Do I have a pair of coefficients with the same numbers? Are those coefficients opposite signs? Okay, so let's go through the process. First thing is make sure x's and y's are aligned. So I have x under x and I have y under y. And then I have my constant under my constant. Okay, now do I have a pair of with the same number? I have a 2 and a 2, a 1 and a 5. So these are not the same, but I do have 2 are the same here, and they are opposite signs. So the first thing you're going to do is you are actually going to add these two equations together. Okay, so if it helps, put a 1 in front of here. Watch what happens. We're going to add equations together. 1x plus 5x becomes 6x. Negative 2y plus 2y cancels. It's gone because it's just 0y, and 0y is just 0. Equals negative 19 plus 1 is negative 18. Now I'm left with an equation that only has one variable. So I'm going to divide both sides by 6 and get x equals negative 3. Once I have solved for one of the variables, then we're going to go ahead and plug it back in to either of the two equations. to find y. Okay, so, sorry, baby crying. So we're going to pick one. I kind of like the first one better. So we're going to say negative 3 minus 2y equals negative 19. Add 3. We get negative 2y is equal to negative 15. Right? No, negative 16. And so y equals 8. So negative 3, 8 should be your solution. Go ahead and do a check step on the last one just to make sure. So 5 times negative 3 plus 2 times 8 is equal to 1. That's negative 15 plus 16 is 1. Check. Okay, so this is your solution. Okay. Example number 2. Step 1, make sure the x's and y's are aligned. Nope, they're not. So I'm going to switch it around. I'm going to switch around the second equation. Okay, so I'm going to move this so that 2x and positive 5y is 31. So all I did was switch around and making sure the signs stay the same as they were in the original. So now I'm going to take these two functions and add them together. If, wait, I didn't check. Do I have a pair of coefficients with the same number? 3 and 2? Nope. 5 and 5? Yep. Are they opposite? Negative, positive. So yes, I am able to combine these and eliminate. So I'm going to add and I get 5x. Negative 5y plus 5y is 0. And 31 and negative 16 is 15. So I divide by 5 and I get x equals 3. I'm going to pick an equation here. It doesn't really matter. This one is all positive, so I'm going to do that one. 5y plus 2 times 3 equals 30. That's sloppy. Anyways. Equals 31. So 5y plus 6 equals 31. Minus 6. 5y equals 25, and divide by 5, and y equals 5. So solution should be 3, 5. Check it in the other equation to make sure it works. So I do 3 times 3 minus 5 times 5 is at negative 16. 9 minus 25 is negative 16. It checks. All right, so then the last type is, what do you do if the signs are not opposite? So if you take a look at this example, we have x and x lined up, y and y lined up. I do have coefficients that are the same. So 3 and negative 2 are not, but 4 and 4 are. But they're not opposite. So just like when we wanted to change signs before, we can always multiply an equation by a negative 1. By doing that, now we have a negative 3x, and I'm just going to write it all lined up under here, minus 4y is equal to negative 18. And so now I have opposite signs. I can go ahead and add those together, so I get negative 5x. Now the 4y's cancel, equals negative 10. Divide by negative 5, so x equals 2. And then you can take whatever equation you want. Use the original ones just to make sure you don't make any mistakes with substitution. So 3 times 2 plus 4 times y is equal to 18. 6 plus 4y equals 18. 4y equals 12. Sorry, because I subtracted 6. So divide by 4 and you get y equals 3. So 2, 3 should be your solution. Let's go ahead. Every time. I don't know what happened. I'll just rewrite it. 2, 3 should be your solution. Plug it in to check into one of the equations you didn't use already. So the bottom one. Negative 2 times 2 plus 4 times 3 equals 8. Negative 4 plus 12 equals 8, and that does check. Okay, So that's the easiest method so far when you have coefficients that are already set up, or you maybe only need to multiply one of them by -1.